So, yeah, let's discuss derivative of an odd function and why that would have to be an even function. So we're given that the function itself is an odd function, meaning it's going to have to satisfy this condition. And we have to show that the derivative, if you put in a negative x, you just get the same thing as just putting in x. That's what you have to show using this one. So we start with a definition of derivative of any odd function, or any function for that matter. It's this. Just starting with a definition. Now, first, I'm going to insert negative x. Okay, so we can factor out a -1 to get this. And the reason for I'm doing that because I want a negative of some input so that I can use the symmetry properties. So because they're odd functions, what we can do is we can bring out this negative outside, right? Everybody can see that. So we can do this. It becomes positive when you bring it out. Okay, so all we need to do here is to switch the order of these two. Like that. Now, you need to visualize this, and then you'll know why this is the same thing. If you visualize this, we have a function, and here's x. Where's x minus h? So x minus h, if h was positive, it's on the left, but actually h is approaching from both sides, right?
Yeah.
So it's actually the same thing. You can see that visually. So x minus h would be here, and x plus h would be here. But the x minus, so the expression x minus h can be here too if h was negative. Right, so there's no difference between this expression and x plus h. Right, x plus h is just starts from here, but if h was negative, it would be on the other side. Does that make sense to everybody? Okay. So that's graphical interpretation that gives us confidence that this is the same thing. But I can say, okay, well, I want to just, for my own sake, algebraic, I want to make sure it looks exactly the same. Let that be some other letter.
A.
A.
That's what I was thinking.
Okay, then you get x is equal to a plus h. And you can rewrite that. Right, so we're still involved with h. So f at a plus h, that's what I can replace the x with, minus f at a, all over h. Now this is equal to f prime at a, right? By definition. But as h approaches to 0, what's happening to a? A is approaching x. See that? A and x are equal to each other as h approaches 0. So we've shown that this right here is equal to this, which is same thing as showing that it's an even function. So there you go.